Imagine a single insect, smaller than your thumb, capable of delivering pain so severe, grown men have wept, convulsed, and begged for it to stop. Scientists have ranked it at the very top of the insect sting pain index, above the tarantula hawk, above the warrior wasp, above everything. But here is the question that keeps researchers up at night. Why? Why does a bullet ant sting hurt so much more than anything else on Earth? And what is actually happening inside your body when it does? Stay with us, because the answer is stranger and more terrifying than you think. Deep in the lowland rainforests of Central and South America, from Nicaragua down through the Amazon basin, lives Paraponera clavata. It is one of the largest ants on the planet. A worker can reach over an inch in length, about 2.5 centimeters. That alone sets it apart. But size is not what makes this animal famous. It has a stinger. Long, curved, and attached to a venom gland that produces one of the most complex chemical cocktails in the insect world. Bullet ant colonies nest at the base of trees in the forest floor. Workers forage up into the canopy, sometimes climbing 30 meters or more, searching for nectar and small prey. They are disciplined, organized, and if you disturb them, they do not forgive easily. Local indigenous communities have known about this ant for centuries. Many have names for it that translate roughly to the same thing, the ant that stings like a bullet. The name was not chosen casually. In the 1980s, an entomologist named Justin Schmidt did something unusual. He let insects sting him. Deliberately, repeatedly. Over years, he was stung by dozens of species and created what became known as the Schmidt Sting Pain Index. The scale runs from 1 to 4. A sweat bee scores a 1, barely noticeable. A honeybee sits at a 2. A paper wasp, a 2+. The bullet ant is the only insect on the scale to score a full 4+. Off the chart. Schmidt described the sensation in his notes as, and this is a direct quote, pure, intense, brilliant pain, like walking over flaming charcoal with a 3-inch nail embedded in your heel. That description comes from a trained scientist who chose to be stung. Now imagine experiencing it without warning. The pain begins within seconds. It peaks fast, and unlike a bee sting, which dulls after a few minutes, the bullet ant's venom keeps firing nerve signals for hours. In some documented cases, the intense pain has lasted over 24 hours. What makes bullet ant venom so uniquely devastating is a single compound, a neurotoxin called Poneratoxin. Most insect venoms work by triggering inflammation or by causing tissue damage. Poneratoxin does something different. It forces your nerve cells to fire uncontrollably, repeatedly, without stopping, by locking open specific ion channels in the cell membrane. Your nervous system is built on electrical signals. Normally, a nerve fires, then resets. Poneratoxin removes the reset. The signal just keeps going. The pain signal keeps going. Your body cannot turn it off. This is not accidental. Poneratoxin appears to have evolved specifically as a defense mechanism, not to kill, but to cause enough pain that any predator, no matter how large, immediately retreats and never comes back. From an evolutionary standpoint, it is an almost perfect weapon. You do not need to kill your enemy. You just need to make sure they never forget the lesson. But for one group of people, the bullet ant is not something to avoid. It is something to endure, on purpose. The Satere-Mawe people of the Brazilian Amazon have practiced a coming-of-age ritual for generations. Young men who wish to be recognized as warriors must wear gloves woven from leaves. Gloves packed with hundreds of live bullet ants, stingers facing inward. They wear the gloves for 10 minutes. They must not cry out. They must endure. And it is not done once. A young man must complete the ritual 10 times before he is considered a true warrior of the tribe. 10 sessions, hundreds of stings each time. Witnesses report that after the gloves come off, the hands are shaking uncontrollably. A direct result of poneratoxin disrupting nerve and muscle function. Some individuals experience temporary paralysis in their hands and arms. And yet, they return. Again and again. Because in the Satere-Mawe worldview, pain is not the enemy. Pain is the teacher. In the wild, bullet ants have few natural predators willing to take them on directly. Most animals learn, quickly, to leave them alone. The giant anteater is one of the few exceptions. Its thick, coarse fur offers some protection, and its long, sticky tongue can sweep up dozens of ants before they can react. Even then, anteaters are selective. They hit a nest fast and move on before the colony can mount a full defense. Because when a bullet ant colony is threatened, it responds at scale. Pheromone alarms go out instantly. Workers flood the area, and they are not shy about using their stingers. Bullet ants will sting insects many times their size. They have been observed taking down prey far larger than themselves by working together, stinging repeatedly until the target cannot move. The venom that causes such extraordinary pain in mammals works as a lethal paralytic agent on smaller invertebrates. The same compound, different target, completely different outcome. Scientists have not studied Poneratoxin purely out of morbid curiosity. The compound has genuine medical research potential because Poneratoxin interacts with ion channels in such a precise and powerful way. Researchers have explored whether its mechanism could help develop new classes of painkillers or lead to a better understanding of chronic pain conditions. When a compound can produce such extreme, controlled, reproducible nerve activation, it becomes a useful tool for mapping exactly how pain pathways work in the human body. The bullet ant is not just a curiosity, it is, in some ways, a key to understanding our own nervous system. So, why does the bullet ant hurt more than anything else? Because its venom was not designed to kill, it was designed to be remembered. Poneratoxin hijacks your nervous system and forces it to scream for hours until every nerve in the affected area has no choice but to obey. It is the result of millions of years of evolutionary pressure on an insect that cannot afford to lose. One ant versus a rainforest full of things that want to eat it. Its answer was not claws, not armor, not speed. Its answer was pain, the most effective deterrent in the insect world. And if you ever find yourself in the Amazon, moving through the undergrowth, look down, watch where you step, because somewhere beneath the leaves, Paraponera clavata is there, patient, alert. And it does not give warnings twice. If you want more stories from the most extreme corners of the animal world, subscribe. New videos every week. And next time, we are looking at an animal that can survive being frozen solid, boiled and exposed to the vacuum of space. And it is smaller than a grain of sand. You do not want to miss that one.